All right, welcome everybody. I know that we're a few minutes late. I will try to keep us on pace here. But want to do a brief introduction here. We're talking about taking your build pipeline, and actually, can everybody hear? Is this good? Okay, great. We are talking about taking your build pipeline to the next level. So the things we'll go through, I'll give you a little intro about myself. Why should you listen to me? And then we'll go through the things, different steps depending on where you're at. You may find yourself in one of these steps already, and how do you get to the next level from there, right? So normally in a crowd of this size, we usually have a few people in the crawl stage. Maybe you're building things locally on your machine and you want to automate. And so this is going to be just a progression of where you're at. I'll go through some of the more intro sessions faster. So if you do find yourself there and want to learn more, happy to talk to you more at our booth. So a little bit about me. I was an Android and iOS developer, but I'm just going to talk about the Android side. For about 10 years to start my career, and moved over into the DevOps space where I've been for about 8 years. So now I'm a pre-sales engineer with Bitrise, basically talking to large companies, understanding where they're at and how do we take them to the next level. So that's where we're at here. About Bitrise, if you haven't heard of who Bitrise is, we're a mobile-first DevOps platform. So this is CI/CD specific to mobile, and also like the part that we'll talk about at the end, which is more into build cache, right? Also fully managed cloud-based service. So as we get into your journey in terms of like where you find yourself and why does it matter? Usually when we get in this progression and we start to automate, the reason we get there is because, as you know, as developers, I would presume most of you are developers here, the reason is the most time that I spend building a feature isn't writing lines of code. It's finding where I need to make that change. And if I have to wait an hour, even 30 minutes, to find out if my change was good, that's time wasted for me. If I jump into another task, a lot of times I lose my place. And so sometimes I'll opt for getting some coffee, or in longer instances, some customers we talked to, they were going to the grocery store while waiting for an hour build. And that's not uncommon. Not to say that you're ineffective at your work, you're still getting your work done, but it's adding to a little bit longer days, a little bit more time spent. So, where are you at today? Again, we'll go through all of these. The goal is, it's hard to get to the fly stage on day one, right? So I want to take you through a progression of how to get there. Usually I find most of the audience is going to be probably in the run stage and looking to get to fly, which is where we'll spend most of the time today. So first, in terms of what is automated CI/CD, right? Taking the build aspects that you're running locally and moving them to either self-hosted machine or some ancillary machine outside of your local build that is working on building that either out to the next environment, QA, test, staging, or even out to production. Why would we do this? Obviously, happier customers, right? Fewer bugs making it out because it's automated, more productivity from you all, from the developers, and then also quicker to roll back or push new changes, recovering from incidents. Now, it's a little bit expensive to get started, especially do this at scale. Obviously, there's hardware involved, specifically for Mac. For Android, you can build on really anything, but I would presume most of you probably build on MacBooks because cross-platform. So Mac specifically for iOS becomes a challenge. Also an environment, maybe a virtualization layer if you're looking for a repeatable setup. There's orchestration in the fleet if you have more than one machine. You've got to work on those things. All right, image distribution, creation, lifecycle, all of those things become some organizations have a team of usually 4 or 5 people managing all of this for the mobile team, definitely at scale. So this becomes a challenge. This is something also that Bitrise does for you. So if you want to talk more about this, happy to go into it. I put a little meme there, but we're mobile specific, and so we have the latest and greatest hardware that you'll find, right? Intel is going away in the next few weeks on Bitrise, but we have M1, M1 Max, M2, everything that you would need to build there. This is kind of what it would look like. I'll try to fly through some of this. So why would you want to improve on your build automation, right? As your team grows beyond a handful of developers, build times take longer. There's more dependencies. There's more other libraries, maybe internal, maybe external, you're taking advantage of. And then also test coverage grows, right? So we need to work on getting that time to build down so that you're staying in context without having to switch back and forth. Also, as a bigger team, you want more throughput. Your organizations are hiring more developers to push more throughput, right? Sometimes even they want to do more with less. How can we not backfill a position where somebody left and still get the same throughput that we had? Right, so these are some reasons why. I talked on the left of kind of the steps and what we're looking for here. So how can we do that? First step, if you're just building locally on one machine or on one CI runner in-house, parallelization is a way to speed that up, right? Essentially taking tasks, maybe one big build job and breaking it out into a few different tasks to speed up. This is going to help you organize. Ultimately, your processing time doesn't change any. You're reducing the wall clock time of your build, right, by splitting that up. This looks, I'll build this out. So essentially break your big pipeline job into some manageable workflows, right, or stages. So I have a stage that does linting, for example. Actually, I think I have an example here. How do I go back? Yeah, so I'll run maybe some linting pre-checks, right? If those fail, then we don't need to worry about running the rest of the build. Let's send it back and get those things fixed. Then we want to run through some testing. If the linting and the testing work, obviously the tests take a long time, so we want to run those in parallel. If all of those work, then let's go ahead and build our APK, AAB, things like that. Let's see, so I think we talked about most of this in terms of why we want to parallelize. Obviously, faster builds. It does take some more infrastructure, but the payout there in terms of speed is great. The next part, dependency cache. So I don't want to presume everybody understands what cache is here, so I'll give you a brief background. Essentially, a cache is we're taking something that we frequently access, and instead of having to download it over the web every time, we're going to put it in memory. It's more expensive, but the download speeds are a lot faster, right? And so it's something that's not frequently changed, but frequently accessed, where I want to take advantage of this. And so all cache really is key value cache, right? I have a key, I want to go get some value cache, pull it down, and then I have my dependency. All right, so we talked about what gets cached, anything that's used frequently, doesn't change much, right? Essentially, we're doing task avoidance here. These are like Gradle dependencies. You may have some things in like Nexus or Artifactory, other internal dependencies, right? These are things that can be cached and save you on build time. What kind of speed up can you expect from some of these things, right? We talked about the crawl. I made it exceptionally long here, right? Because maybe you're doing a cross-platform or something and you need to run Android and iOS all in one build, but even just the Android piece, right? We clone, we run some kind of dependency installation, build, run unit test, run end-to-end test. These things take a long time. When we parallelize, we're essentially cutting in maybe in half, maybe even more to save those times. So maybe a 60-minute build could take 30 minutes if we cut it in half with parallelization. Where the key value cache, maybe it doesn't take it as, minute-wise, cut down on your build time a lot, but because we're taking advantage of cache components, this does have a meaningful impact in your build time as far as that goes. So this is in Bitrise. If you wanted to use it, we have pre-built steps to do all those things. So the part that I'll spend the bulk of our remaining time on would be the fly section. So I presume most of you have gotten to the point where you're building an automated fashion, you have parallelized as best you can, and you're running dependency cache. How can we get that next step, right? And that's where there's a few things we'll have to go into background about. There's alternate build systems, which is what we're talking about here. Predominantly, most of you are probably just Android, are using Gradle. Comes out of the box with Android Studio, and Gradle build cache is a part of that build system. If your organization has grown even more, you might be taking advantage of a system called Bazel, or if you're also doing iOS, using Twist. So those are other tools that you'd want to take advantage of to speed up your build even more. Bazel, we'll talk about that in a minute. But why would you do it? Obviously, as your team grows, as the lines of code grows, your build time exponentially grows, right, with tests. Also, we talk about productivity dropping. As those times grow, productivity drops a lot. There's a lot of time wasted because of the large team. Obviously, organizations are looking to optimize. Some examples that I have a customer that we were working with, actually just wrapped it up recently. Their build time locally, in CI was 45 minutes for their Android build. With the build cache, their build time was 1 minute and 23 seconds. So crazy build time, and we'll talk about how we can do that. So some of the common tooling, I'll skip over the iOS specific ones, XE Remote Cache and Twist, we won't worry about those. But Gradle and Bazel are the two that we'll focus on here. Gradle comes with Android Studio, right? Bazel was an internal project developed by Google and is more of an advanced build system. This can be used to beyond mobile. A lot of organizations use this to build iOS, Android, backend, middleware, like everything gets built with Bazel. So why would we do this? How are you getting that 90, almost 100% improvement in your build time? So if you think of your build, the output that you're looking for as broken into multiple projects, right? And all those projects are broken into multiple tasks. If you've ever looked in your build output, you might see, hundreds, thousands of tasks that Gradle is compiling individually. All of those things are determined by inputs, right? So I may have multiple inputs that feed into a task, and so there may be thousands, tens of thousands of tasks running as a part of the Gradle build. In order to speed this up, we want to take advantage of avoid rebuilding something where the inputs haven't changed, right? So you have a fingerprint of that task, inputs haven't changed, then we can avoid rebuilding it. This is how your local builds are much faster, unless it's a clean build, are much faster. So it's already built into Gradle to do this locally. We're just moving to how can you take care of this in CI. So task is avoided if your inputs don't change. Excuse me. If your input is changed, it rebuilds the task. Now, on a small stage, doesn't seem that impressive. Excuse me. On a larger stage, you can see how this can really make a difference. So I change one input only, which the majority of builds are incremental in nature. a lot of tasks can be avoided. So, in addition to avoiding tasks in CI, this remote cache can also be taken advantage of by developers locally. Feeding that cache from your CI builds, but making that so that you as local developers don't have to do a clean build from your machine. You can always take from CI, speeding that up even more. What does this look like? In CI on the top here, developer triggers a build from like a commit or a PR or merge. We're going to download any things that didn't change in cache. Anything that did change, we're going to upload to your build cache. And then for a local developer, we're going to check for changes, download, and so you don't have to worry about clean builds even locally. This has a huge impact on your speed. So, is it worth the effort? Setting up Bazel is no small task. Usually, I think a couple years ago, this used to be a year-long effort for a large team. The speed improvements are great, but you need a full-time team managing that. Now, it's usually to move to Bazel is 3 to 4 months, usually what I've seen. I've seen some teams do it faster with some help, but usually it's still a meaningful effort. The great thing for Android, it's already built into Gradle. So you don't have to do a lot of work to get that extra benefit. To get the exponentially faster build times, that consistency in your builds for large teams, and obviously what we care about is more developer happiness. So there are some bottlenecks that step into play when we talk about moving to a build cache. How can we optimize this? I think Gradle did a study about this. Let's say you put your server in US West and your US West team has the best time savings. It was like, 3-4 minutes on a 10-minute build. I can't remember the numbers exactly. But US East, where you all would be, had like maybe a 30-second improvement. And then if you go to Europe, they might not even see a benefit, right? So geographic distance plays a huge role in how performant the cache can be. Also, read speed is important, and the network protocol is also important. We talked about implementation time already. So geographic distance, right? Where do you need to place the cache to accelerate your builds in CI, as well as for local developers? This is easy if everybody is in New York, right? If everybody's here, no problem. Unfortunately, with I don't know if they've made everybody go back to work in the office yet, but I have a lot of friends that moved out of the city, right? Moved away, and now you have a distributed team, or maybe you've got teams East and West Coast. This can be a challenge. You either have multiple server actually we can talk about. So the way that you solve this is with a CDN, right? So I'm going to put multiple POPs, points of presence, close to where your CI is or to where your developers are, to allow you to take advantage of that performance. The next part is slow cache reads. The reason this is important is a very simple app has thousands of tasks, right? Your applications probably have orders of magnitude above that. And so reading even from a solid state drive is 100 times slower than an in-memory read. Now, that sounds great, but can we move all this to in-memory? That would be, the cost would be astronomical, right? In-memory reads are so much more expensive. So what we've done is we created in the CDN in-memory storage, and there is some secret sauce that Bitrise does to help manage cost and make this more performant. We'll get to some of that. There's also content-defined chunking, so maximizing your reuse, maximizing things like that. to make this more affordable. All right, and then the last thing, protocol. So a lot of CDNs, actually the majority of CDNs, run over HTTP 1. And the challenge with this is the type of transactions that you're having with the cache. This affects Bazel more than it does Gradle, but it's similar output. It's a lot of TCP connections, reading header, waiting for a handshake, and it's a bunch of small transactions. The solve for this is gRPC with HTTP 2. It's faster because it's a longer lived connection that's streaming and optimizing for session reuse, right? So fewer handshakes, better compression, which also helps on some of your speed. All right, and I am almost out of time. So the last piece, like how can Bitrise help? If you were looking for a solution that does this, we're happy to help. We have remote cache in the same data center as your CI builds. If you have CI already and you just want to add cache, that's also something that we can do. So we can manage all of that and you can keep the CI that you already have. You will have better performance out of keeping them in the same data center, but I'll also have customers that do have a lot of success just taking advantage of the cache. Obviously, you're looking at 90+% speed improvement over a clean build that you're having today in your local. The CDN infrastructure has a couple advantages. So faster local builds, obviously, because of the closer proximity. It's also a lot more economical. Egress out of a major cloud is like 10 times the cost of egress out of a CDN. So you have it's a lot more economical to have that network set up. And also we have gRPC streaming, so it gives you faster speed and also more economical. So this is what it looks like in Bitrise, what the build times look like. This is for a DuckDuckGo open source application. And yeah, that's it.
5 minutes for Q&A.
Perfect. So I ended here. How fast can your app build? Also, we can talk to you at the booth, give you a free trial where you can try this out in your apps, see how it performs. Cool. Any questions?